All right, you're in the overview for Module 9. And this is the last learning you'll learn for the semester, which is great because if you'll notice, you have your test and bonus is at the beginning of next week. This is for test 4, and then your final falls right after it, and it's only open for 2 days. So basically you finish test 4 and you move on to the final. So you could have been working on these bonuses or most of them all along, but if you want some more practice, you can go in and work a bonus that includes a lot of the questions for more practice. So this module right here, there's a homework set for this one, but the homework set for these are all combined into one longer homework. Don't forget you do have a drop homework, so if you don't get perfect on that one, you might be okay if you're doing fine the whole other parts of the semester. So you're going to be looking at kinetics, rate laws, and energy diagrams. So the kinetics of a reaction, it's just how fast is the reaction. It depends on orientation and speed. And you'll learn about like some theory about like the kinetics and why kinetics are what they are. Then you'll learn about predicting or calculating rate laws. So you'll get tables that are larger than this one. Like they're longer and they're larger. Something like it'll be a long table. And you'll use the information in this table and this generic rate law to calculate a real rate law. And by a real rate law, I'm meaning one that has a value for this and a value for this. So first thing is you'll use these to calculate the value for M, and then you'll go back and pick a row and plug everything in to figure out the value for K. And then you'll have the rate law. So this one has to do with using information in a chart and like a generic equation to make a specific equation for a specific reaction. It'll make more sense when you see it, but I just want to let you know that it's coming up and you're going to be working with charts and stuff. And then energy diagrams, if you remember very much from high school, this is a real popular high school topic where like this distance is activation energy and this distance is your delta H. And then like in here, again, activation energy. And then this whole thing is, and then that distance is delta H. It's endothermic when you end higher, and it's exo when you end lower than where you started from. So those are energy diagrams. And then you're going to go into elementary steps of reaction and integrated rate laws. So the elementary steps, it's where you're solving. You can solve these problems. You get like everything on the left added together, and then you get the right. You cancel out what's the same on both sides. This is kind of like what I was mentioning several weeks ago when you were manipulating K's. You get up to here. So this section right there, this is where you take everything on the left-hand side and add it up, and then you have the right-hand side. And if you had things on both sides, then you would cancel it out. So you're going to be doing that again. So we're cycling back to that same method. But then also, if you know what the slow step is, there's a way to get the rate law from knowing what the slow step is without having to use a table and do these extra table calculations. It's a quick thing. It has to do with how many reactants are right there. And then we have the integrated rate laws. And the integrated rate laws basically just have us, if we know the order of the reaction, 0, first, or second, then they're going to give you information and you just have to plug in the right equation. So there are 3 kinds of equations, but you'll notice like all the equations have an A. All the equations have a K. You see that? All of them have this A naught term. So it's like you'll get the same information. You'll get 3 out of the 4 variables. And you have to make sure that you know if it's 0, first, or second. And then let's say it's first, then you know to use this equation and plug and chug. And then there's even a way like this K right here is related to that K. So they can give you this, then you can get the K, and then you can plug and chug and get, like, let's say you were missing T, but you had those other 2 values. So anyways, those are the integrated rate laws. And again, it's plugging and chugging, but it's just you have to make sure that you're paying attention and you pick the right equation. And finally, radiochemistry decay calculations. This equation that I have written here for the mass defect, it looks really, really complicated, but it's just the number of protons in an atom times the mass of a proton, which is given to you the number of neutrons times the mass of a neutron, and then the number of electrons, the mass of electrons. You add them up. And you subtract from that the mass of the nuclide, which is that number you get from the periodic chart. It's really close to the number on the periodic chart. And then the difference in those 2, that's the mass defect. And then also, you will use this version of this equation to calculate how much changes, like you'll deal with it for half-lives and stuff. So this is great for calculating, like after a period of time, if we know what the substance is and its half-life, if we know it started with this much, how much mass would be left over. This also has you practicing your log skills. You'll do erase to the fun times again. And then finally, you get to end on something that you may not have ever seen before that's pretty interesting. There's alpha decay, negatron decay, positron decay, and there's neutron bombardment. And you'll learn about those reactions. You'll be able to predict the products, and it's just different and unique and kind of a nice way to end the whole semester. And I just want to say congratulations for you for staying with all of this material. This is a lot of material in 10 weeks, and just great job on keeping up with it and doing really, really well and hanging on there to the final test and the final exam.